Why are we not surrounded by antimatter? Introductory level. Why are we not surrounded by antimatter? The answer? Because the electron electrically interacts with itself in a different way that the positron interacts with itself. What is antimatter? This is matter. This is a hydrogen atom formed by a proton and electron. This is antimatter. This is a anti-hydrogen atom formed by antiproton and a positron that is an anti-electron. It has been experimentally observed. The known laws of physics predict that we should be surrounded by antimatter, but we are not. Why is antimatter important? This is a water molecule formed by an oxygen atom and two hydrogen atoms. This would be an anti-water molecule formed by an antioxygen atom and two anti-hydrogen atoms. However, it never has been experimentally observed. I and ions are full of water. Anti-ions should be full of anti-water. The known laws of physics predict that anti-ions should exist, but they do not exist. If the known laws of physics predict that we should be surrounded by antimatter, why are we not surrounded by antimatter? The answer? That is not the answer. Many physicists could explain to you that it is because something happened at the beginning of the universe 13.8 billion years ago. As a result, the matter-antimatter symmetry was broken. What did happen? We do not know, but we will know, maybe, they may say. Why are we not surrounded by antimatter? An answer that actually is the answer. Please pay attention to this. This is the electron and a positron. Both have the same mass. They have opposite charge. The surprising answer to why are we not surrounded by antimatter? Because the electron electrically interacts with itself in a different way that the positron interacts with itself. Did you listen it? Because the electron electrically interacts with itself in a different way that the positron interacts with itself. Absurd! Impossible! The known laws of physics state that neither the electron nor the positron can interact with itself. This is because they are mathematical points, point particles without dimensions, with null radii. A wise man will say, please, explain this. I am listening. Thanks. Let me explain. Non-relativistic quantum mechanics state that there exists a wave associated to each quantum particle with mass larger than zero. There is a particle, there is a wave. Classical particles are different than quantum particles because there exists no wave associated to a classical particle. Physicists solve wave equations to obtain the wave that is associated to the quantum particle in different conditions. Now, this is important. Relativistic quantum mechanics state that there exists no one but two waves associated to each particle with mass larger than zero. The energy of the relativistic quantum particle is different in each wave. In one wave, the energy is E plus mc2. This is the wave that is known in non-relativistic quantum mechanics. mc2 comes from special theory relativity. But the relativistic quantum particle can be in exotic state, where the energy is E prime minus mc2. This exotic state exists in quantum mechanics when a special theory of relativity is included on it. Physicists solve relativistic wave equation to obtain the two waves that are associated to a quantum particle in different conditions. Similarly, the same occurs for antiparticles. This is the meaning of the theoretical matter-antimatter symmetry. The energy of the relativistic antiparticle is different in each wave. In one, the energy is E sub A plus mc2, and in the exotic state of the antiparticle, the energy is C prime sub A minus mc2. Physicists solve relativistic wave equation to obtain the two waves that are associated to a quantum antiparticle in different conditions. Attention, this is new. It has been demonstrated that if the antiparticle electrically interacts with itself, and if the antiparticle's electrical charge is greater than the Planck charge, the Planck charge is around 11 times the charge of electron, then the exotic wave where the antiparticle energy is E prime sub A minus mc2 collapses to a point. Therefore, it disappears. When this occurs, the antiparticle is transformed in a classical antiparticle. If the charge of the antiparticle is larger than the Planck charge, the antiparticle is classical. Breaking the symmetry. However, the electron electrically interacts with itself in a different way than the positron interacts with itself. Therefore, the particle's electrical interaction with itself never produces a collapse to a point or neither one of the two waves that are associated to a relativistic quantum particle. For any electrical charge value, the particle is a quantum particle. This breaks the matter-antimatter symmetry. Why anti-ions do not exist? Relativistic quantum mechanics state that atoms are stable if and only if their nuclei and electronic clouds are quantum objects. This meaning there are two waves associated to the nucleus and two waves associated to the electronic cloud. Antiatoms could not exist. This is because their nuclei and positron clouds would have a too large electrical charge. Therefore, they would be classical particles. Classical particles cannot form stable atoms. Anti-ions should be formed by antiatoms. However, these antiatoms do not exist. Therefore, anti-ions do not exist. Why do we exist? Relativistic quantum mechanics state that atoms are stable if and only if their nuclei and electronic clouds are quantum objects. This meaning there are two waves associated to the nucleus and two waves associated to the electronic cloud. Atoms with many electrons and protons exist. This is because there are two waves associated to the nucleus and two waves associated to the electronic cloud in matter atoms. Therefore, they form stable atoms. We are formed by stable matter atoms. This made possible our existence. Interesting, but absurd, impossible. Are you denying the known laws of physics? No. I only try to complement them and to explain why the world is as it seems to be. Do you know why it that nobody has ever seen the Schrodinger cat? This meaning a cat that is simultaneously dead and alive? Because it does not exist. Do you know why the Schrodinger cat does not exist? It has been demonstrated that if a particle or antiparticle gravitationally interact with itself. And if the particle mass is greater than the Planck mass is around 20 micrograms, then the wave where the particle energy is E plus mc2 collapses to a point. Therefore, it disappears. If the mass of a particle or antiparticle is larger than the Planck mass, the particle or antiparticle is classical. Summary. If quantum mechanics is correct, then there is a wave associated to the particle. The energy of the particle in this wave is E plus mc2. This is the wave studied in non-relativistic quantum mechanics. And if a special theory of relativity is correct, in addition to the previous wave, there are exotic states where the energy of the particle is E prime minus mc2. This wave exists in relativistic quantum mechanics when a special theory of relativity is included in quantum mechanics. And if a quantum particle or antiparticle could interact with itself, then why are we not surrounded by antimatter? Because the electron electrically interacts with itself in a different way that the positron interacts with itself. If the charge of the antiparticle is larger than the Planck charge, the antiparticle is classical and the antiparticle exotic state collapses to a point. Why are we surrounded by classical objects? If the mass of a particle or antiparticle is larger than the Planck mass, the particle or antiparticle is classical because the wave function associated with the energy E plus mc2 collapses to a point. Interested? There are 3 more videos about this topic. We invite you to watch the next one. The middle level video titled Observing Matter-antimatter Asymmetry. A rigorous presentation of these ideas can be found in the book titled Relativistic and Non-Relativistic Quantum Mechanics, both at once, authored by Luis Grave de Peralta and his collaborators, and published by Spring Nature in 2023. In this book, the Poveda-Poirier-Grave de Peralta equations are presented and discussed. These are the relativistic wave equations to whom we previously referred. Thank you very much.